In this video, we will be dividing polynomials using two different techniques, and in general, synthetic is preferred because it's simply less work, but you can only use it when you're dividing by a linear factor. And in number 2 and 6, no method is specified, which means you could use the method of your choice, but I'm going to demonstrate how you should approach these. When you're given a choice, if synthetic is an option, you should take it. So on number 2, we're dividing x cubed minus 1 by x plus 1. And since x plus 1 is a linear factor, we can use synthetic, so we're going to. And remember, synthetic division starts by taking the 0 of the thing you're dividing by, which in this case is x plus 1, and the 0 of the factor x plus 1 would be negative 1. So we put a little negative 1 in a box here. In fact, let me make that a little smaller, make sure I have plenty of room to show you this. And then you list the coefficients in descending order, starting with the first term, which would be x cubed. So our first coefficient would be 1, but then any missing term, that is, any missing power, you're going to put a 0. So this was the first term, the 1 was for our cubic term, this 0 I just wrote was for our squared term, so this one would be for my linear term, and then I have a constant, negative 1. So then you put your bar down here, and bring the leading coefficient straight down, and then you multiply the number outside by the number at the bottom and bring the product up. And negative 1 times 1 is negative 1, so we write that under our first 0 there. And then we add those two, excuse me, add those two numbers to get negative 1, and then we multiply again. Negative 1 times negative 1 is 1, and bring that up to the next available spot. Add, and we get 1. Multiply down, bring the result up, we add, and we get negative 2. And then we translate that into an answer. And our directions actually said to write our answer two ways, in polynomial form and in fraction form. And we will mostly be using fraction form, but just so you can get comfortable with what each method looks like, we will, for this first set, write it two ways. So polynomial form simply looks like this. You take the name of the polynomial, and of course that's f of x equals, and then you write the product of the thing you were dividing by and the result. Now this is where we translate from our synthetic, and the bottom line below your bar always gives you the coefficients of the terms of a polynomial of one less degree than the thing you were dividing into. So that tells us that our first term should be an x squared term, and since its coefficient is 1, we just won't write it. And then we have a negative 1, so the next term in descending order of power would be an x term, so that's going to be minus x. And since we've had a second degree term, a first degree term, our next term would be a constant or a 0 degree term, so we put plus 1 and close the parentheses. We then put our remainder outside by writing minus 2. And the more common one, the one you need to know better, I'll move it up here and write it a little larger. And a lot of times we won't write the left side, but this is really what the left side would be, because typically you'll just put an equals behind the problem as it's described. But this one you just write the polynomial from the bottom, so that's going to have a similar set of terms related to the polynomial form. So this is the thing that we got at the bottom, and then you always just write that, and then your remainder you write minus 2 over the thing you divided by, which of course in this case was x plus 1. So this would be your fraction form. Same set of directions on number 6, but the problem with this one is that we do not have a linear factor that we're dividing by, so we're going to have to do good old long division. So it's not really hard, it's a little more to write, but hopefully you'll get it if you didn't know how before as you go through this example with me. So just like in the good old days, you write, and when I say good old days, I mean you did long division by hand in elementary school. We put the thing we're dividing by on the outside, and then we do this, looks like a parenthesis with a bar. And inside there, we write the thing that we are dividing into, which in this case is, for some reason I'm having trouble making this x to the fourth minus 3x cubed plus 6x squared minus 3x plus 5. Make sure your bar goes all the way down to the end. Alright, and then once you set it up, you look at what you have, which is your first term, x to the fourth, and you ask yourself, what would I multiply my leading term of the thing I'm dividing by to get x to the fourth? So what would I multiply x squared by to get x to the fourth? Well, obviously that would be x squared. And it's a good habit to get into to just write that term where it lines up with its like term inside. And then we're going to distribute that to the individual terms of whatever we're dividing by. So x squared times x squared is x to the fourth. And then x squared times 1 is x squared. So I don't want to write that under the cube. I'm going to come over here and write it under the squared term. And just like in good old long division, we're going to subtract what we just got from the terms that are there and bring the result down. X to the fourth minus x to the fourth goes away, and that should happen every time. If it doesn't, you did something wrong. Alright, and then I have minus 3x cubed with nothing subtracting from it, so I'm just going to bring that term down. And then 6x squared minus x squared would be plus 5x squared. Okay, and then now that I've done that subtraction, I bring down the next term, which would be minus 3x. And I go again. And I ask myself, what would I multiply x squared in the x squared plus 1 by to get negative 3x cubed? Well, that would be minus 3x. So again, I write that right behind the first term I wrote at the top. And my answer is forming as we go. So we're going to distribute that negative 3x to x squared plus 1, and we get negative 3x cubed. And then negative 3x times 1 is negative 3x. So again, I make sure I line it up with its matching term. And then we're going to subtract what we just brought down. So now we have negative 3x cubed minus negative 3x cubed. Again, that goes away. And again, I have this middle term with nothing to subtract from it, so it just comes down as part of my next step. And then I have negative 3x minus negative 3x, which makes that go away. So I've lost that term, and now I have one more term to bring down. So I brought the minus 3x down there, and now I'll bring down the plus 5 here. And one last time, I will ask myself, what would I multiply x squared by to get 5x squared? And pretty quickly, obviously, I hope that's plus 5. So I distribute the plus 5 to the x squared plus 1, and 5 times x squared is 5x squared. 5 times 1 is 5, and then we're going to subtract. And obviously, that's exactly like what I had, so that's going to be 0. So in this case, we have no remainder. So we'll write our answer both ways. The polynomial form would be the thing we were dividing by, which was not x plus 1. Now I'm just thinking about the last one. X squared plus 1 is what we divided by. Times x squared minus 3x plus 5, close parentheses. And then in this case, we don't even need a remainder to add to it because we would be adding plus 0. So this actually turns out to be our f of x. Let me erase that arrow out of my way so I can put the f of x in front. So that should be our f of x in polynomial form. And then our fraction form would be f of x divided by x squared plus 1 equals, and then we just write the numerator, or not the numerator, but the answer, which is x squared minus 3x plus 5, and that's fraction form. And that box did not want to make properly. There we go. And that's both forms of that answer. Then we have number 8, and in 8 and 12, in this particular set, you are told to use synthetic here. which I would do anyway, even if they didn't tell us to, because we're dividing by a linear factor. So remember, you write the 0 of the factor outside, and then your coefficients, and fill in with zeros any that are missing. So 2 is an x to the 4th coefficient, and then I have -5. And when you write these on your paper, you want to make sure that you leave some space, because if you get them too bunched up together, it just makes a mess. So 2, -5, 7, -3, 1. Because we have a 4, 3, 2, 1, 0 power. Everything's there. No zeros are needed on this one. So then I put my bar across, bring the 2 down, and multiply down, bring the result up, and add. Multiply down, bring the result up, and add. Multiply down, bring the result up, and add. I'm sorry, that is not -27. Try that again. That's 27. Multiply down, bring the result up, and add. And then we only have to write our answer one way. It specifies fraction form, which will be typical. So this is what I was saying earlier, when you won't necessarily have to write anything on the left side, because literally you could put an equals beside this and then say this is equal to, and remember that when you translate from synthetic, the first coefficient, or the first number, is the coefficient of one less degree, because if I divide a 4th power something by a linear something, I end up with a cubic something. So this is 2x cubed plus x squared plus 10x plus 27. And then we're going to stick our remainder under there, which would be plus 82 over x minus 3. And that is our fraction form answer for number 8. On number 12, now this one looks really simple, but be careful here, because this one, if you notice, we go from an 8th degree term to a 0 degree term. We're going to have zeros on this one. And this is one of those where you really, really, really want to be careful about how you space your terms. So go ahead and put that -2 out front in its box. I'm going to see if I can get this to squeeze in all the way across the screen, so I don't want to write too big. So I've got my -2 here, and then I have x to the 8th, which would be 1. And then I'm going to leave a little space, and you'll see why in a minute, but I'm going to spread these out. So that's my 7th degree, 6th degree, 5th degree, 4th degree. That's not a very pretty 0. For some reason my 4th degree 0 does not want to be there. So we have 8, 7, 6, 5, 4th degree. Now we need a 3rd degree, a square, a linear, and we have a constant, so we put -1 at the end. Alright, and then we need our bar to go all the way across. We bring down the 1, multiply up, and add. Oh wait, my bad, that was -2. -2 times 1, that should be a -2 and a -2. So now when I multiply that, I get a +4. Bring down the 4, then I'm going to multiply that up and get -8. And then I'm going to bring that down, multiply up, and get +16. Bring that down, multiply up, and I say bring that down because we're just adding to 0. So this one becomes -32. Multiply that by -2, we get 64. Add that to 0, we still have 64. Multiply that by -2, we get -128. Bring that down after we added it to 0. Multiply up, and then we get 256. And then when we add 256 to -1, clearly we get 255. And then we write our result in fraction form. And this is a very long answer. So here we go. And we'll forego the left-hand side on this one. X to the 7th minus 2x to the 6th plus 4x to the 5th minus 8x to the 4th plus 16x cubed minus 32x squared plus 64x minus 128, and then plus 255 over x plus 2. And that whole long thing is our answer. And I'm just going to underline it. I'm not even going to try to make a box around that. And that is the end of our second video.